Hello everyone. Today I'm going to show you how to train a VGG16 deep learning model on a custom dataset. Our dataset has two classes. It has cats and dog images. So in this tutorial, we'll go through the following steps: installing necessary packages, loading the data, splitting the data into training, test, and validation set. We will going to train our model on training set, validate our model on validation set, and finally test our model accuracy on test set. We will also show you how you can plot our accuracy and loss graphs. We will test our model on some sample test set. Finally, we will learn how we can save our model and we can load our model for future use. About me, I am Dr. Noman, PhD from Edith Cowan University, Australia. Before beginning, if you are not familiar with setting up a Python environment or configuring your computer for this project, please check out my first video where I explained it in detail. This link is available in the video description. Now let's get started. You need to search Anaconda prompt from start menu or search button. Just here, you can Anaconda prompt. Here is our folder. We have created this folder last week. So this is our dataset. Dataset has three folders: test, training, and validation. Training has two, every folder has two different datasets. So like one is cats, another is dogs. So it's cats images, and this one is dog images. In this tutorial, I am sharing all of my resources, dataset, code to the video description. Please find all of these resources from video description links. So we need to navigate our Anaconda prompt, this folder. So we need to copy this one and paste cd, write down cd and paste it here. And we need to activate our environment. Conda activate my ML. So we activated our environment that we created last week. In this environment, we need to install some packages. I am going to install some packages. So just these packages. So we need these packages: pip install tensorflow, matplotlib, scipy, scikit-learn, seaborn. This kind of packages we need. So I'm going to install. So most of them are installed already. So after that, we need to go to the Jupyter notebook. So it is Jupyter notebook. So you can go here, new, and you can write down your code here. So I have created a Jupyter notebook for this training. So this is our all of the packages we need for this project. So now I am going to import all of these packages. So you can see it is running this code. It imported all the packages. So now we need to load our model. So we need to base the layer so it will not train the weight of the previous model, base model. So we are training our model on the binary dataset. So our class is 2. So we are using activation function sigmoid. And this is our model. We can compile our model, and before training we need to compile. So we can see our model. So this is all of the VGG16 model. You can see there is a convolution layer, pooling layer, max pooling layer, flatten layer. All of this layer is here. So this is the total parameters, how many parameters, trainable and non-trainable parameters. Now we need to work on loading our dataset. So our dataset has training, test, and validation. So in the training, we will do some data augmentation, like we'll be scaling, rotating, shifting, zooming, this kind of data augmentation we will do. It will give you more training sample, and it is very good for the getting more accuracy. and we will validation. We are not doing any data augmentation in the validation. So training, we got 204 images. Validation, we got 119 images, and test, we got 131 images. So now I am going to, so we are going to just 10 epochs, so not much more. So for the real cases, you need to train this model like a 200 or 500, like for your, depends on your data set, like a big epoch, so that you will get more good accuracy. For I'm showing here like a showing you just small epochs because it will take less time. So now I am run this one. Yeah, it is, see, you can see that it is training. So we have best size, we put how much best size, we put best size a best size 8, means that it is taking 8 images at a time. So after finishing first epoch, we can see our accuracy is, by training accuracy is 0.5, means 56%, and loss is 2.1313, and validation accuracy is 0.67, and validation loss is 0.95. So after 2 epochs, we can see it is accuracy is like 55%, and loss is little bit decrease the loss, validation accuracy improve, and loss decrease. So if you increase the accuracy and loss is decreased, that is good, like your model is performing good. So we need to wait until 10 epochs finish. So this is how we can train our model on binary data set. So before finishing 10 epochs, it is almost finished. We can see accuracy is improving. So there is like a good improvement here, like a training accuracy. These are the training accuracy and training loss, validation accuracy, and validation loss. After, when the 10 epochs will finish, we'll save our model and we will test our model on the test data set. It is almost going to finish. It is very quick because I made a very small data set. On the real cases, it like you have to be perform on very big data set, so that it will, like sometimes it takes like 10 days, 15 days, depends on the data set. So you need a very good machine to perform this kind of uh, operation on the data set. So accuracy, good. So accuracy 56. Now after 7 epochs is 84 training, and I'm waiting. Validation is almost 90% accuracy. Epoch numbers 8. So best size is 8, so that it divided the whole data set, like a training data set is like a 204 divided by 8, so it is 1826 for each epoch. It is taking 8 images at a time, so 8 is just total is 26. Almost very close to finish. So after 10 epochs, we can see our training accuracy is 81%, and loss is 0.35, validation accuracy is 93, and validation loss is 0.21. So now we are going to save our model and performing. So this is our test set. So we are going to see how does our model is doing on the test sets. So accuracy is like very good accuracy, 84%. So we need like a more epochs. So like when like more than 200 epochs to make sure that our model, then we can see it's a good like almost 97-8% accuracy. So we can print that is like accuracy is where test accuracy and loss, test loss, we are going to print. So we already printed here 84 and loss is 0.3. So we are going to plot the graph. So this is our graph. So see, this is our graph. So this one is validation and training. So our accuracy was improving during the training time. So training and both validation and training, it was improving. Like it started 50 and it is going almost 80, more than 80, and validation is started less than 60 and it goes like almost 90, 95. Yeah, almost. Now I'm going to perform, I want to see the loss. So loss is decreasing. It is good, like a model accuracy is improving and loss is decreasing. This is good. Now we save our model. So if we go to our folder, so we saved our model. Now I am going to load out this model. So I'm going to load this model and I will perform some. So this is cat. So our model can perform, if I put number images like in the testing set, I have like images. If I test on the testing like a image mod, it can, it is 90%, 99% confident it is cat. If I go like number two, we can see what is number two. It's a dog. See how our model, what it can predict. It is dogs 99%. Number three, it is dog 70%. It is, see, it is looking almost cat, so it is like a very, it is a little bit confused, but it is still predicted correctly. So now, thank you for watching this video. Please like, share, and subscribe. All of these resources will be available at the video description. Thank you so much.